Do children still need to learn how to code?
It's one of the defining questions of our age.
I still get to solve the problem and enjoy programming.
Are we allowed to use this? Is this cheating? I don't know.
Am I going to be replaced by a robot?
Maybe teachers are not as part of this equation as much as we would like.
Welcome back to Hello World, a podcast for educators interested in computing and digital making. I'm James Robinson, computing educator and aspiring AI aficionado.
And hello, I'm Veronica, a research scientist here at the Raspberry Pi Foundation, and I've previously worked as a software engineer. I'm really excited to speak to our guests today about our question, do children still need to learn how to code? As ever, we really value your comments and feedback, which you can share at helloworld.cc/podcastfeedback. James, to start things off, what do you think about today's question? Do children still need to learn how to code?
It's a really interesting question. And of course, we're not going to have all the answers today. And I think I'm going to kick things off by talking from fairly personal experience of engaging with AI and trying to use it for some programming. I think in my work, I've written a few kind of short scripts and macros and explored kind of APIs that I'm unfamiliar with. And I think where I found AI really beneficial is as a tool that can help speed up my programming. I can ask it a question and it can give me a piece of code that probably won't work first time, but it gets me through like layers of an API that I'm trying to explore so that I can get to the sort of the crux of the problem that I'm trying to solve. And I think for me as a novice kind of amateur coder, I think it gives me it's empowering. I think it increases my efficiency. But I still think like there is the requirement of programming knowledge in order to fix, to iterate, and to improve and to solve problems and integrate it into wider kind of challenges. So I think my personal view, and it might change over the course of this episode, is that whilst the nature of what kids need to learn to code might shift, I think there is still a need for it. I think it's just that the type of knowledge we need might be changing slightly because we have this tool that can support us. So that's my view. What's your thought, Veronica?
Well, I agree with you, James. I think it is a really, really interesting question, and certainly from a research perspective as well. And I think it's nice to contextualize. We're asking this question because the substantial progress that has been made in the area of large language models in the last year or so. And there are studies that have shown how large language models like ChatGPT can complete first-year undergraduate computer science programming tasks with a really high degree of accuracy. So my thoughts on this are, first of all, why do we program? And certainly, why do we think it's important that young people learn how to program? Because there are, on one side, there are the programs, the apps, and the websites that we write and we want to get to that are the end product. But there's also that process of engaging with technology, creating with technology, that I think enables young people to engage with technology as creators rather than consumers, that I think is more meaningful. And I think programming is a big part of that. And I think that is potentially even more relevant now with the increased prevalence of AI, the use of AI. And I think the fact that we have tools like ChatGPT that can generate sensible solutions, code solutions to some problems, definitely does have implications on what we teach and how we teach, I think, on assessment, on plagiarism, on the learning objectives we might have around programming. For example, here at the Raspberry Pi Research Center, I'm working on a project looking at the use of large language models to explain syntax error messages to students, which is yielding really interesting results in terms of what educators value about programming. And it's not necessarily just getting students over the errors and to working code. It's a lot about the process that students engage in that debugging process. So I'm really excited to explore this question with people that will know a lot better what they're talking about than our guests today.
You saying that, Veronica, has made me think. I think there's something about that you're right, that process, right? I really enjoy programming, except for when it's really frustrating. And so if I don't have access to a more knowledgeable other, like a professional programmer who can solve my specific challenge, well, actually, maybe I can turn to AI as a knowledgeable other to help me have that kind of dialogue. I still get to solve the problem and enjoy programming, but I don't have to wait for a forum response, maybe, and someone to understand the problem I'm trying to solve. But enough from us. We should get our guests in the room. So our first guest is Pete Dring, Head of Computing at Fulford School in York. He develops innovative teaching resources for computer science. So Pete, what do you think about this question of whether kids need to learn to code? Is it relevant? And what are your thoughts?
Yeah, it's a great question. And I think it's one of the defining questions of our age in many ways. I think the big decision in society is, am I going to be replaced by a robot? And there's a lot of fear and a lot of misunderstanding. Um, so do we need to learn how to code? Well, it's not a life or death, yes or no. If a student doesn't know how to code, they might lose out financially, they might lose out in terms of career options. But for me personally, the reason why I enjoy programming is it's a creative problem solving activity. And I want students to have every opportunity to thrive. I want them to be innovators, creators, the people who can solve the problems of the future. Um, so, yes, I think we're changing the way that we code. I really like the way that you said that, James. But if we want our students to have the best possible chance of thriving, we need them to understand what the machines are doing for them rather than just relying on something else. Because it won't just make things easier, it will also make things less satisfying. And I want students to get that creative buzz out of understanding exactly what's happening when they solve their own problems.
Excellent. No, thank you. And welcome to the podcast. Veronica, would you like to introduce our second guest?
I certainly do. Welcome, Chris. Chris has taught computer science for 24 years and is currently completing a PhD in computer science education at Abertay, Dundee. Chris, welcome and thank you for joining us. We are talking about coding and the impact of AI on coding and programming. What does that term mean to you and the coding that term mean to you, and how do you perceive that impact?
Well, the word coding covers a manner of sins here, because I think back to when I was a child and what coding meant then. And coding meant when your parents bought you a new magazine with some words in it that started with 10, go to 20, and you coded a game, which was basically typing words into a computer terminal that made the computer become this live thing where it suddenly reacted to a button press and there was a thing that flashed and there was lights and it was interesting. But over time, the word coding has sort of shifted to be so slightly more than that, because if you were to ask the average 11-year-old here in England, so do you code? They would say, well, of course, I use Scratch. But there's no typing there. They're dragging and dropping blocks that have similar meanings to what I did when I was a child. There's go to this, click that, lights flash. But so I suppose nowadays you have to say coding is almost like speaking computerese. So I speak Python, I speak Java, I speak Scratch. It is, I can communicate my ideas in a way that a machine can understand it. And that's, I think that is the sort of the broad idea of what coding is now. What coding looks like in the future, nobody knows.
That makes a lot of sense, Chris. And I think I really like the way you put it, speaking computerese, and also in terms of what coding was originally intended to, was to communicate with computers, right? So whether it's text, low-level programming, high-level programming, and the reason why we say high-level programming is because it's maybe more similar to natural language communication. It's about that communication with computers, which takes different forms.
I think, yeah, I'm really interested in that kind of that explanation and definition. I think for me, when I think about coding, I really think of it as a subset of programming. right? Coding is the bit where you take your intent and you turn it into something that the computer can understand. So whether that's, Python or a block-based language or whatever. But if we think about, there's the levels of abstraction model, which includes design and programming, understanding the task, and then the execution as well. The coding is like one layer within that, of taking your design and writing it in a way that the computer understands. The executing and debugging is a different set of skills. So that's where I kind of position coding in this space. And I think it's interesting. And I wonder whether, when we think about AI in relation to coding, whether the AI is purely doing the sort of the coding bit, or whether it's also able to support the design, the other aspects of what we think of, or what I think of maybe as programming. Yeah, I don't know if anyone has any other thoughts on that. That's just my view of programming and coding.
I really like what Chris has said in terms of describing algorithms and the way that that's changed. I think with the ease of being able to generate algorithms and code with AI, I've seen a lot of memes going around of people worrying that, oh, my job as a software developer is over. There's no purpose for me. But if we roll back the definition of what it means to write code, to unambiguously, without any room for disagreement about meaning, describe exactly the functionality of what a program's going to do. Yes, you can do that in Scratch, you can do that in JavaScript, you can do that in Python, but you can also do that by speaking in natural language to artificial intelligence. You can do that very quickly. It's a low bar to entry. But actually, if a student wants to do that definitively, to pull out all of the edge cases, to make it crystal clear exactly how it's going to behave in a larger project, all of the detail that you'd end up putting into any programming language, you'd have to communicate with AI. It's just a different way of representing definitively, unambiguously, what that algorithm needs to do.
That's a really good point. And we've got the whole range of things we could talk about here. I'm really interested in both of your experience in engaging learners with coding and AI. What kinds of activities and experience have you seen? How are learners perceiving the large language models and their utility when it comes to coding? And what experiences have you got? Chris, do you want to chip us off with that?
Yeah, so this fascinates me no end because in the UK where I'm based, we have to do these sort of like what other countries might call homeworks or something like that, that sort of cumulatively adds up towards your final grade for the subject. And it's always been this really interesting thing where pupils are sort of pretending to be real life coders, and they have to meet with their client and they develop this solution for the client. And this process can take a couple of months because they then have to sit there and code and they have to research how to code. And in walks ChatGPT in November last year, and a pupil puts his hand up and says, "Sir, I think I can do this whole thing in a couple of hours." And I go, well, that's a really interesting problem that you've just created for yourself, because we're going to have to wait and see what the people that run the exams say, if this is okay. And they don't know, that we don't know. So it's sort of turned what used to be for 20 odd years a very nice progression of we have to do this, then this, then this, then this, then this. It's made an incredible shortcut that now we're wondering, are we allowed to use this? Is this cheating? Is this not cheating? I don't know. So it's really interesting to me.
I want to come in on that before I bring Pete into this, because I think there's something really interesting there about the artificial nature of learning to program in a kind of formal education setting, particularly when it comes to examinations, because it's been a long time since I was in the classroom now, but I remember back then we're doing controlled assessments and that kind of thing, and the artificial nature of a programmer sitting down in isolation and deciding a solution for a specific problem, when actually in reality all the programmers and developers that I knew in the real world were writing collaboratively and using GitHub to do things like version control. And so that examination was quite separate from how coding was actually being done in the real world. And I think now it's a similar kind of thing, but we're seeing, we have this other access to other knowledgeable people who can support and collaborate with us. How do we as educators address that and help understand what actually the learner can do by themselves? Anyway, that was slightly tangential. Pete, what's been your experience of this in the classroom?
Really mixed. It depends on the age range. So a couple of memorable moments where some GCSE students, so age 14, 15, we were going through some theory. I teach a practical GCSE where students have to have an exam in controlled conditions. They're allowed to, so they have to sit for 2 hours and write some code. They're not allowed access to the internet. They're not allowed to use generative AI. They do have a syntax reference guide, and they can use that to solve some problems. It starts nice and easy, debugging some code that's broken, filling in the gaps, and then the harder questions involve complete blank canvas. So the end result for us at GCSE for the qualifications, the students have to be able to code independently. They've got to be able to debug. They need to problem solve. They don't necessarily need to remember the syntax. They can look that up. But they need the practical experience of writing code. So we have some lessons that are to do with Python, writing Python, some lessons that are theory-based. And in a theory lesson, we were using, it was Microsoft's Copilot rather than ChatGPT. We're talking about different sorting algorithms, and we were implementing them in Python to consolidate the theory. And I did a really terrible job of implementing live coding, a merge sort. I would have failed a job interview at most software development companies. But then we talked through the concepts of the theory. We attempted using the skills that the students had learned by that point to apply it. We tested it. It obviously didn't work. And then we went to generative AI. It really quickly generated some code that was actually quite similar to what the students and I had developed. And because we'd put the groundwork in to understand the concepts first, they were able to say, oh, that's the bit that we were missing, and we could use that to debug ours. And then on the other side of the spectrum as well, sometimes it helps to go straight into the AI and say, okay, well, can you implement this for us? And the AI does a terrible job. So known algorithms, AI is brilliant at, but something like, can you write some code to draw a picture of a cat that is, I don't know, holding a sausage in its mouth or something ridiculous like that? It will generate some code that draws something, but it's definitely not a cat with a sausage in its mouth. And at that point, you've got a starting block to build on with your creativity. So it's a tool that students can use, but it's definitely not something that they can rely on in isolation.
Another way this has sort of come into my awareness is every year when we have this, normally this time of year, pupils come up and they say, oh, I'm interested in studying this particular course. Computer science is one of the courses, and in computer science there's coding. And for many years now, one of the first questions you ask kids, or they would even volunteer and say, yeah, I really like coding. That's why I want to do computer science. But for the last about year and a half, maybe 2 years, I have pupils coming into quite senior levels of computer science, so age 17, 18, going, no, I don't really like coding, but I really like computer science. And you go, my word, these people exist. You always put them together. You always think that, well, if you like computer science, you must like coding. And for a while in the UK, at least, we had this dirty thing called IT, which was sort of how to use computers. And that was sort of a dirty sort of sidetrack to pure, proper computer science. And it's fascinating. And I'm wondering if AI is not possibly sort of the hint of things to come, as in the way that pupils interact, or if they think that AI is like another tool for them to use, then coding almost becomes annoying, and I'll just get the AI to solve that bit and I'll do the things that I actually enjoy, which might be how to write the ethics of whether something is piracy or not. And I'm wondering if we are sort of becoming very obsessive about AI. Yes, but we should keep AI away from coding because, God, that might be the end of our subject and it would be terrible. But I'm wondering if kids feel that way.
It's really interesting. Pete?
I find that actually really exciting, Chris, because I think that creates opportunities to add more diversity to the subject. I think it's great that a wider varieties of personalities are finding different aspects of our subjects to love. And I think the best analogy that I've heard is the invention of the pocket calculator in maths. Maths hasn't changed as a subject for, it seems like, millennia, although mathematicians would argue otherwise. Uh, but when this device came along that proved that all of the skills that were drilled into you from a very early age seemed irrelevant because something could do it much faster, much more accurately, much more reliably, people were saying, well, do we still need to learn timetables? Do we still need to know algebra? What's the benefit? Surely a computer can just replace all of those processes. So then we look at the benefit of knowing general arithmetic, times tables in society, and there's still a role for that. I'm sure we've all been in a queue at a supermarket getting quite frustrated when people don't have those skills. But then also in assessment in schools and universities, we have one exam in maths where students do use a calculator. We have one exam in maths where students don't, and different students will enjoy either depending on the specific type of practical skills, mathematical skills, which are both valid.
And I think I was going to make this point earlier on, but I think our question for this episode is, do students still need to learn to code? And I think actually maybe that's quite a binary question. Maybe we could be phrasing that, to what extent do our learners still need to learn to code? Because I think for some learners, AI is going to be the tool or the enhancement that means they can actually start to create the ideas that are in their head, and coding doesn't, hold them back. And for others, it's going to be this powerful source of sense checking and a collaborative partner. And I think it's just about finding ways to kind of deploy this tool in a way that is most useful for everybody. Yeah, Veronica, I know you've got some questions. Should we move on to some other aspects of this?
Yes, definitely. Well, I do have a question, and I do want to tie into what both Pete and Chris were saying about kind of these nice consequences to broadening participation and broadening what computer science means and the way people engage with it and get involved in it, which I think is really interesting. And I think on the other side of the coin, some might worry about the autonomy that students might feel in if a tool can generate exactly what I'm being assessed on or asked to produce, then they might feel a reduced sense of autonomy in the meaning of what they're being asked to do or what they are learning. And I wonder whether you have some thoughts on that, on whether you've seen any evidence at all in your students on this maybe potential reduced autonomy that students might feel, and in what way do we need to change or adapt our learning objectives to make sure that autonomy still remains? Chris?
I think it's interesting that we're speaking to two teachers here, because teachers are obsessed with measuring things. And the same as you would with athletes, we would feel very aggrieved if we were measuring our pupils to run a race and we were to find out that one of them had been taking steroids for the last 3 years. That would be a real problem for us because it's unfair. And so what we have now is this weird situation where, because fairness is now somehow more important than ability. So the AI makes things possible that weren't possible before. But now we're so worried about this. Is this fair? Is this right? Should we be doing this? That we're saying, oh, let's rather not. And so that's, to go back to what Pete was saying, that's why for some of these exams, they're saying no calculator because that's unfair. But with AI, it's a bit difficult because it's not a singular box with the same 17 buttons on it. It's difficult. So, for example, can I still measure a pupil that has access to ChatGPT 4 and a pupil that only has access to Bing Chat and some people that doesn't have access to anything? Is that fair? And I think it's not so much the autonomy that pupils struggle with, it's the fairness. And if you have brothers and sisters, the fairest thing in the world is who slices the cake. And this is exactly that fairness problem that AI creates, that is perhaps more accentuated in teaching and learning and that aspect of education generally, because we need to have a definitive answer. How good are you? Are you an A pupil? Are you a B pupil? And how do I know this? Is by testing and measuring you to within nth degree. And um, so is AI going to mean that you are just a better pupil if you can make AI do better things, or are you a better pupil if you don't use AI in the first place?
And maybe that comes down to what our measurement of better is. Like, because if we are measuring, can you write a piece of code that does X? Well, then AI gives you an advantage in that arena. But if we're measuring something else, and I don't have an answer for that, but if we're measuring, like, can you explain what this piece of code is doing, or something like that, it's a different question. It's a different skill set that we're measuring.
Which is a lot harder to measure, if we're
Right,
honest.
it
I mean,
is.
it's significantly easier to measure. Can Johnny say print "Hello World" to can Johnny, I don't know, create a cat with insert name of object in mouth?
Yeah.
So
Can they explain what this code is doing? Well, it depends as well. Like, to what extent? Like, because I can say, well, it's going to display a message, or I could say, well, it's a function call that takes this as a parameter, and like, it's a much harder thing to assess. Pete, did you have anything to add?
Yeah, thank you. So we go back to some of the building blocks of our subjects. We've got abstraction and we've got decomposition. So we teach from a very early age that computing involves hiding unnecessary detail to focus on the most important thing. It doesn't mean we completely take away that important detail. It's still important, but at different stages of people's learning, at different stages of people's careers, there are different things that we need to focus on as the most important thing. And I think I was teaching year 12s, so that's 16, 17-year-olds recently, and we were introducing low-level computing assembly programming. And some of the students said, oh, thank goodness that we don't have to do this anymore because higher level languages exist. But they also said, well, it's fascinating now that we understand it, because now we understand what's going on inside the CPU, what the registers do, how to control it. But we spend less time actually implementing that low-level assembly code and worrying about what the registers are doing because we're empowered to use the higher-level programming language. And I think that's what is going to allow us to take place using artificial intelligence. Most of the time, for most people, students won't have to worry about the specifics of certain types of syntax of code. But does that mean that there's no benefit at all of digging down into how it works? Well, no, absolutely not. My wife's an artist, and she she admires other people's art. There's great benefit in looking at art that other people have done, but it doesn't compare at all to creating it for yourself. There's more creativity, fulfillment, satisfaction in doing that. But she's a stickler for actually wanting to understand the process, to work out what types of paint do different things, learning new techniques, sharing those techniques with other people. So I'd say you can see a game, you can play a game, you can choose and have autonomy about creating a game, or you can actually understand how it works. And at each stage, there's a different level of abstraction. And at each stage, AI can help us with the creative process. But at each stage, the detail of how it works is still absolutely crucial for students to be able to learn.
I think there's a risk here, and the risk is the same as with my electric car. Like, my dad told me how to change a spark plug, and that was really useful. I have no idea what's going on in my electric car. I plug it in and I drive, and that's all great. And I have a concern that if we have pupils that completely disengage with this nuts and bolts, what's going on beneath the hood, that we are going to have a generation that just does honestly think it is magic, or there's this artificial human, which it might be, I don't know, that creates things on your behalf, and then crucially that has to fix things when things go wrong, because even the most amazing AI isn't flawless. So there would be a problem that pops up, and then somebody has to have the skills to look under the hood. Now you might argue, well, get another AI to do that, but I'm concerned. It's almost on the same level, I suppose, where people worried about if everybody rents an apartment, who's going to be the one that builds them? It's I don't know.
I think it's really interesting. I think it feels like we're kind of at an inflection point, and we were at an inflection point about 10 years ago in the UK where we moved away from a very ICT focused subject because we felt as a community, as a profession, that it wasn't empowering. It was leading students to not understand sort of things that were going on under the hood, and so we added, or maybe actually shifted, towards pure computer science. And we've been studying and focusing and developing that for the last 10 years or so, and now we're at this next inflection point where a disruptive technology has come along. It is potentially, really, really, really powerful as a skill to understand and deploy, but it also has the potential to disenfranchise our learners. And 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 I think that means it's imperative for us as educators to really think about what is the subject that we teach for. And I like the way that Pete explained it earlier on, that it's not just about making an end result or a product. It is about the exploration and the study of this wonderful subject. And sometimes that means understanding the detailed nuts and bolts. You did make me think, Pete, I wonder if AI can write good assembly code yet. I haven't tried that. Be an interesting experiment to see. But yeah, so I think it is imperative that we are mindful that we don't reduce our knowledge of the subject, our discipline, down to what can we produce with a computer, and therefore what can AI produce with a computer, whether that's code or media or whatever. Our subject is richer than that, and it is full of conceptual understanding that is valuable, in intrinsically valuable, not just for a purpose. I'm going to get off my soapbox now, and I'm going to see if anyone else wants to come in.
I think we've hinted on a couple of dangers with artificial intelligence, and I think one that rarely gets talked about is the environmental cost and the financial cost, because we're used to things like Copilot and ChatGPT, which are to a certain extent freely available. Actually, when you try and implement your own large language model on your own computer and you see just how much processor resource and memory it requires, it's vast. And there's data centers out there consuming electricity, producing carbon dioxide, and the cost of that has to be taken up somewhere. But there's two aspects. One is, well, do we want students to have to rely on this hugely potentially damaging resource just to be creative? Surely sometimes I enjoy cycling and walking. I'm a stickler for wanting the latest gear, but I also like just going outside without a waterproof or without walking boots or anything like that. Sometimes it's nice to have the gear, but sometimes it's just nice to enjoy the thing in itself. And I think if our subject is to be creative, we want students to not have to rely on all of this extra stuff that has cost to the environment, and also potentially restricts access to reliable internet connection in a Western country, with access to artificial intelligence through the big companies that may or not provide it for free in future. We need to safeguard the democratization of our subject so we don't become reliant on a technology that it can be controlled in the future.
I'm concerned about the financial aspect here, because AI has the potential to be a little bit like a drug. And I find myself now adding ChatGPT as a favorite on my browser and referring to it quite often. And if I'm doing it, I can sure as heck think my pupils are doing the same thing. And if at some point in the future it suddenly sits behind a paywall, or there's some financial thing to it, I can imagine it will be a little bit like streaming video services. You feel sort of morally obliged just to remain in your social circles. Of course, you have to know what's going on in this episode, so you will subscribe for £2 a month. But no matter what the financial barrier is, there would be a barrier, and that splits the planet into the haves and the have-nots. And unfortunately, I think AI isn't one of these things where you can go, well, the have-nots will just be a little bit worse off. they will be substantially worse off. If I have to think about the speed, back to going to my original example of that pupil developing this solution that is ultimately going to give him a grade that will allow him to go to a university of his choice, that will have a demonstrable impact on the rest of his life, just that access to this thing. And equally, if this was behind a paywall, and increasingly you sort of get the idea that they might go that direction, or at least, I don't know, you can use this as long as you say the word ChatGPT every 10 seconds, then that's great. And I'm just concerned about where that might lead.
Well, I think that goes back to that point of fairness that you made earlier on, Chris. And yeah, it is a really important aspect. And I think you both mentioned, Pete, you mentioned like your example of how you used it with students and how nicely you I think you referred to putting the groundwork in to then go to the sorting algorithm and discuss it with students. But it was useful because you put the groundwork in. And also, Chris, in your example with a student who took 2 hours to do something that normally you do over a few months potentially, I wonder what you both think around what is that groundwork and what are those fundamentals around programming that you think need to be there for students now, that are there for students now and need to continue being as we teach programming, whether we have access to large language models or not?
I think that depends on what the destination is. What do they have to be able to do with the coding? Because that massively influences the granularity of what you need to teach. If they have to put a message on a screen, then they have to know the coding for output. If they have to put a little pyramid on the screen, they might decide they might have to know iteration or a for loop or something. So, and to that extent, I think maybe teachers are not as part of this equation as much as we would like, because ultimately the teachers are teaching for the most part around the world to an exam. And so it's all about the measuring stick that determines what they should know. So on a sort of a more meta scale, what should pupils know? It's a bit like being a doctor. Well, it depends what kind of doctor you want to be. I suppose you need to have a basic idea of human anatomy, but if you're going to be a neurosurgeon, do you really have to know how the bones regrow or something? I don't know. There's some parallel there for me in computer science, with specifically with coding, because it used to be quite. We knew where we were going. They had to have these particular coding skills as a fundamental base level. So, for example, with web development, they had to know what HTML tags are because they have to make web pages. But include AI in that massively fast forwards that. So is that still the first thing I have to teach them, or is the first thing that I teach them how to write a prompt in an AI that generates the thing?
Can I jump in on there? I think that's such a powerful question and a really good answer, Chris. Thank you. I think depending on who you ask, you'll get a completely different answer to what is the groundwork. But for me, an outsider's perspective, whenever a relative or a friend gets introduced to me as a teacher, they think my job is to impart knowledge, to somehow get students to understand things. And there's an aspect of that, but the vast majority of my time is convincing students to want to care and then teaching them how to ask questions rather than answer them. And we can only impart information if students are receptive to receiving it. And I think AI is brilliant at disseminating information in a much more accessible and personalized way than even the best teacher thinks that we're able to do. However, I've not seen yet a way for AI to motivate students in computer science and programming and software development and problem solving or any other subject, but also in prompting students to come up with the prompts required for AI. That has to come from the curiosity, from the creativity, from the drive and the desire to think, I want to make something new and I know what I want it to do. And I just need to be able to find the tools, the language, the method of articulating that to make it a reality.
That's a really nice answer, both from Chris and Pete. Thank you. And I also wanted to pick up on that point, Pete. I wonder if do you feel like the way in which you motivate students changes at all in view of these tools?
You have to ask my students, and they'd probably take issue with the assumption that I do actually manage to motivate them. Different things work for different people, for different personalities, but absolutely, yes, if there's something out there that can reduce the frustration, if there's something out there that can create more sense of achievement in less time and effort, then yeah, I want that. It's definitely a useful tool to add to the things that are available in the classroom.
I think it's important to remember it's a tool. It's a tool. And it just like a calculator is a cool tool, this is a tool. And I have yet to see a child that I teach that doesn't get fascinated when there's a new thing for them to play with. That's human nature. We like poking in the sand at the little animal bones. We like doing this. So I think the motivation is perhaps easier than what we would like to admit, because some of it could be quite self-serving. I mean, the most important thing to a teenager is him or herself. So they really want the thing that will help them get to their perceived finish line. If their finish line is academic achievement, great. But if it's just to finish the assignment so Mr. Coetti can stop shouting at me, that's an equal good payoff in many respects. So yeah, motivation.
You made a really nice point, Chris, about engaging educators and teachers and perhaps not having done this too enough in the past. And I wonder if you have any thoughts on how to better. It's something that we think a lot about at the Raspberry Pi Foundation. Certainly in the research team, we try and engage with educators as much as possible. But there's also so many kind of logistical limitations to that, and time and so on. And I wonder if you have any thoughts on that, and specifically as we move to the field changes so much and so quickly, and I think the topic will change so much. So I think we need to engage with educators better and quicker and shorten that loop of the way we enact changes and potentially the curriculum or assessment. And I wonder if you have any thoughts on that, on how for us to better do that.
Well, some things change really quickly, and some things don't change very quickly at all. It started the academic school year, so we went for some academic CPD training, and it was all about how do kids remember things. And I'm thinking, this is my 25th year, and not much has changed. Kids still remember in the same way. I think the bit that involves educators gets back to is this cheating or not? We really have to come up with an answer for this, because as a society, we have to decide how much credit we can give something that is produced by AI, and then is that a creative credit, or is that an intellectual credit, or is that you are now worthy of moving on to the next stage of your academic life credit? So I think teachers need to be involved in those discussions, at least with the decision makers at that point. I think that's probably a good start, maybe.
Pete, did you want to add to that at all?
Just to say that there was a consultation from the UK government about the opportunities and risks of artificial intelligence, and the opportunities was a short paragraph and the risks was, 10 pages, and it just created a culture of fear of there's going to be more pressure, more accountability, and more questions with very few answers. So if you want to engage with the educator community, if we can have a rigorous discussion about, well, how do we check plagiarism? What is acceptable? How do we support teachers to make sure that we don't have to check multiple versions of students' work multiple times and sign off each one? Because there are huge opportunities, but huge dangers for the profession to feel threatened, to feel put out of our jobs, outside of our comfort zones, even inside computer science, but certainly in other subjects. It's a real area of concern.
That's really important. This is, I think, computer science, we're just slightly ahead because we think we know what the problem is. But this affects my wife's psychology lessons. This affects other subjects. I think the reason we're talking about this in computer science land is simply because computer science caused the problem. So we maybe at ground zero, we know what we did. Start
Let's
running
not admit to
first.
that, Chris. Let's not take responsibility. I guess, I think we're sort of coming to the end of our conversation now, but I think what would be really, we've had like really in-depth conversation, and we've kind of gone all over the place with our discussion. I think what would be nice, just to kind of close the conversation out, is I wonder if anyone's sort of perspectives has changed or broadened. Like, if we think back to the question of the episode, do students still need to learn to code, or to what extent? What's our kind of closing remarks on that? What are our positions? And I'm going to focus on Pete and Chris. How would you summarize this conversation in your mind?
I think somebody needs to know how to code. And if it happens to be the kids in front of me in a computer science classroom, somebody needs to know this as a backup plan for humanity. Because if we keep building on top of things we've already built, at some point, if something goes wrong, somebody has to climb down the ladder and fix the bottom. And if the person who has to do that doesn't know the difference between a for loop and a while loop, I think as a society, we would regret that.
No, I agree with Chris. I think if there's an opportunity for a student to become a more effective communicator as a politician, or to have a wider reach in the science research that they do, or to be more prolific in the inventions that they create, or to be better at communicating in the charity that they work through, there are creative solutions with code that can open doors for productivity and fulfillment in school and way beyond school, that we would be crazy to shut off those opportunities by denying students the opportunity to learn how to code.
What a fantastic conversation that we've had today. If you have a question for us or a comment about the discussion that we've had, then you can email us via podcast@helloworld.cc, or you can tweet us at helloworld_edu. My thanks to Chris and Pete for sharing their time, experience and expertise with us today, and we'll be back shortly exploring more topics to do with computing education. So, Veronica, what did we learn?
Oh, James, it's so interesting, and I could have kept on going and going for another 3 hours. What did I personally learn? Well, I just really enjoyed how we quite quickly, I think, in this podcast went to the basics of what is coding, and those fundamentals of why do we teach coding, and also even what is teaching and why do we do it. And I really enjoyed that, and I enjoyed exploring and identifying there are some things that do change and will change with respect to large language models and AI tools, but there are also those things that don't change and that have remained the same for the last few years and will remain the same. And I think finding those ways of better communicating those and engaging with students and educators to identify those and be clear about them and having fruitful conversations is the best way forward. How about you, James?
I think that AI is here to stay. And I think it's going to have an impact on our classrooms. And I think most important is that I think educators need to engage. They need to think about that impact and be very deliberate, I think, in the choice of how they use AI to support their learners or challenge their learners. Would be what I took away from today. Also, I'm going to go and see if AI can write me any machine code. I'll test that out. Thank you to our guests, and we'll see you soon.